Hello class, this is a video tutorial on the sum and product of roots for quadratics. As seen in previous videos, there are two ways a polynomial can be expressed. Either it's in factored form, or the same factored form can be expanded into a general form. So any polynomial, p of x, can be factored or expanded. And here are just three examples of this. If we were to expand this without any values, leaving the roots as alpha and beta, we would get the following. Take a look and watch very closely on the coefficients of the end result. X times x, x times negative beta, and then negative alpha times x, negative alpha times negative beta. From this, we can factor out x like this, and then just rearranging this so that it is a number in front of x. So it's like we're treating this as if it were a coefficient. You notice how whenever we factorize a quadratic, we're always looking for two numbers that multiply to give us c, and the same two numbers that add to give us b. This here shows exactly that. Alpha times beta, alpha plus beta. Now, since this factored form is congruent, or the exact same meaning as the general form, we can do a little bit more now. So let's take a look. We're saying that this expression that we've just found should be congruent to the general form. However, with the general form of a quadratic, it is not monic. So by dividing by a, we get b on a as the coefficient of x, and c on a as the constant term. By matching the coefficients now, we get what's known as the sum and product of roots. By matching, I mean this term should match this term. Hence, we get negative alpha plus beta should be equivalent to b on a. By moving that negative to here, we get alpha plus beta equals negative b on a, and alpha times beta should be c on a. So these are two identities that we need to learn regarding the roots of a polynomial in relation to its general form. Now, learning all this, it seems rather trivial, but when we see this in action, it'll make a little bit more sense. So let's go straight into it here. So the roots of a quadratic f of x are 3 plus root 2 and 3 minus root 2. Well, by first using this expression, we can easily find the coefficient of x and the not the coefficient, or the constant term b, or c, sorry. So take a look. Alpha plus beta is equal to 3 plus root 2, that was a bit weird, plus 3 minus root 2. And this will give us 6, because these two cancel, giving us 3 plus 3 equaling 6. Okay. Next, using alpha times beta, we can find this term here, the constant term. So alpha times beta, alpha beta, that's going to be 3 plus root 2, 3 minus root 2. Expanding these two, 3 times 3, 9, 3 times negative root 2, negative 3 root 2. Positive root 2 times 3, that's plus 3 root 2. And root 2 times negative root 2, that just becomes negative 2. These two cancel. this will give us 7. So now using these two values from this expression, we have now easily found the values of A and B. Oh, sorry, B and C. So using this, we get x squared minus 6x, because that's what alpha plus beta is, plus 7. And that there is the function f of x. So let's move on to the next example, where we use the sum and product of roots. Let's copy this so that we're not scrolling up and down. So here we go. Now, in this case, we don't know what the roots are. However, we can easily find the sum of the roots as being negative b on a. A is equal to 2, b is negative 6, and c is 1. So alpha plus beta is going to be negative 6 on 2. This is very straightforward. That's positive 6 divided by 2. Alpha plus beta is equal to 3. Alpha times beta, well, that's going to be c on a. So alpha times beta, c is 1, a is 2. And there's our answer. Alpha times beta is just a half. And for the last one, this one's a little bit trickier. Alpha squared plus beta squared. In order for us to get an expression that looks kind of like this, it looks as if it comes from this expression. However, actually, let's do this in a different color just to show you that it's not part of the calculation just yet. When we expand this, we get alpha squared plus 2 alpha beta plus beta squared. Now take a look. This expression has alpha squared and beta squared. So what's missing is the alpha plus beta. Now, using this, I can rearrange this expression to become alpha plus beta all squared. And I'm going to move this to the other side of this expression. It's going to become minus 2 alpha beta equals alpha squared plus beta squared. And now I have this expression equaling this one. So, whoops, this should have been in black. So this expression is equal to alpha plus beta squared minus 2 alpha beta. And we have these values already. Alpha plus beta is 3. So this is just going to be 3 squared minus 2 times alpha beta is half. This is going to be 9, take away 1. So alpha squared plus beta squared is just 8. So I hope you're seeing how this might be used. So let's move on to the last example where we might use the sum and product of roots. In this question, it's saying that one root is double the other. Okay, so first, in order for us to do this, what we will need is to make that expression one root is double the other. So let's say we have two roots, alpha and beta. If one is double the other, we can say that alpha is double beta. So alpha is equal to 2 beta. Well, from this, we can see that A is 1, B is 2, and C is negative 5k. So I'm going to highlight all of it. Using all of this, we'll find the sum of roots, alpha plus beta. But since alpha is 2 times beta, we can replace this with 2 beta. So this becomes 3 beta becomes, and this is the sum of roots, and the sum of roots is negative b on a. So it's going to be negative 2 on 1, because remember there's a 1 here. So beta is actually equal to negative 2 over 3. Then from here, we're going to use the other expression, alpha times beta is equal to c on a. So it's going to be negative 5k on 1. But as we've said before, alpha is equal to 2 times beta. So this is going to be 2 beta squared is equal to negative 5k. We're going to substitute this value for beta. So 2 times negative 2 on 3 whole squared. Expanding this, we get 2 times 4 over 9 is equal to negative 5k. Solving this further, this will become 8 over 9 equals negative 5k. Dividing by 5k, k is equal to negative 8 over 45. And that's the value of k. So I hope that gave you an insight into how we might use the sum and product of roots, as well as the relationship that roots have with the general expression of polynomials. Hope to see you in the next video. Best of luck.